right, so today we're going to be doing radians going around a circle. So I have on here that the degrees were 0, 90, 180, and 270. Now, yesterday we talked about these being quadrants, just like they were back in Algebra 1. They still are these quadrants. We're supposed to tell where these are. And yesterday we talked about 360 was 2 pi and 180 was pi. So that means 90 is pi over 2 and 270 is 1.5 pi, which is 3 pi over 2. And again, you can write this as 3 pi over 2. You put the pi in the numerator, or you can write it as 3/2 and put the pi beside that. We're going to use this same proportion sum today. And the first set of problems wants us to estimate to the nearest half radian. So what that means is if I took my calculator, and I hope we already know that pi is 3.14. And we talked yesterday about what a radian is, that a radian is the radius picked up off the circle and laid here. So like if I took this radius, if I went from this center over to this point and I peeled that off and I laid it on the circle so that this piece was the same length, this would be a length of 1 radian. Okay, that'd be 1 radian. Now, what it means is this being 3.14 radians, it means you would actually have laid 3 of those radii going around here and then had 0.14 more to get to here. So that'd be 3 radii plus 0.14 more to get to here. So that's what that means. Now, if I take my calculator and I take pi divided by 2, so I'm hitting second caret divided by 2 on my calculator, even though I'm not showing it to you. That's this is about 1.571 radians up here. That's what pi over 2 is. And then if I take 3 times that, this is going to be about 4.712. And I probably should have gone 3 decimals with pi. So pi to 3 decimal places is about 3.142. And then if you get 2 pi, that's going to be about 6.283. So I am supposed to tell to the nearest half radian how far around here I'm going. Now again, this would be 1 radian right here. 2 radians would be over in here somewhere, and 3 radians would be in here somewhere. So we got 6 of them to get all the way around. So 4 radians would be in here, 5 radians in here, 6 radians probably in this area. And the reason I'm doing this is that first part wants us to estimate how many radians to the nearest half each one is. Okay? Now they're supposed to be equal lengths, and of course they're not because I'm freehanding this, but if I go back to our homework problem, here's the first problem we want to do right here is we're talking about all the way around to here. We want to know about how many radians that's going to be around there. So if I look at this, 5 radians would be down here, right? Because this picture, there's the beginning, and it says we're going around like this. And to me, that looks like it's about like in here somewhere, is what that looks like from that picture over there. So 5 would be in here, and 6 would be in here somewhere. So I would call that about 5.5 radians is where that's coming from. So I would call this about 5.5 radians. Now, that's one way to do it. The problem is we're not really used to radian measure. We're more used to angle measure. So something you could do is you could say, well, hey, how much would this be in degrees? So if this is 90 degrees here, to me that looks like that's probably about halfway. So that looks like this angle in here would be about 45 degrees. So coming all the way around this way to get back to 360 would make that about 315 degrees. So if I went to that formula I did yesterday, which is this, and I would get R equals 315 pi divided by 180. So if I take that on my calculator, and I'm going to show this to you on the calculator. Okay, there's my camera. Okay, where's my picture? All right, let me see if there's some reason my picture's not showing up. So let me see something here. All right, maybe this will do it. Let's see if this gives me my picture back here, hopefully. There we go. All right, got the picture back. Okay, so I'm going to type in this 315 pi. Take 315 pi divided by 180, because that's what I got up there, and I hit enter. Do you see how that's 5.497? We're supposed to round this to the nearest half. So if you looked at 5.5, so this would be about 5.5 radians, because it wants half. Okay, so that's how I got that. Now this one is going, this one is also going clockwise, so this is positive. Remember, this one's going to be a negative because it's going clockwise. This one is counterclockwise, so it's positive. And it says, I'm going past 360. So to me, this angle here looks like it's probably about, I don't know, maybe 30 degrees. So we're going to say this is about 390 degrees. That might be a little high, it might be like 15 degrees, but I can't really tell. So the only difference is that's going to change this to 390 and this to 390. So when I type that into my calculator to get my radians, and I'll show you that again, what I'm going to do is I'm going to take that thing I just typed in and I'm going to hit second enter. And then I'm going to go back to where the 15 is and make that a 9 and a 0 and hit enter. So that's about 6.8. So I would round that to about 7 radians. Okay? So that's how you're going to estimate these. Coming on down here to the next part here, it says, determine the quadrant in which each angle is. So I'm going to show you what I would probably do if I were you. Again, we could, if you remember around there on the circle a minute ago, we could do this. We could say that's 0, this is pi over 2, this over here is pi, this over here is 3 pi over 2, and then going back up here is 2 pi. And we can put these into radian measure, just like we had over here in the decimal form. We could put down these decimal numbers, and we could say this is 1.571, and this was, I think, about 3.142. And this down here was, what was that, 4.712. And this was about 6.283, if I remember right. And then we could make this decimal on our calculator. So I could take 12A, I'm going to do my calculator. So I'm going to put in negative pi divided by 6, and that's negative 0.527. So this is about negative 0.527. So now we're talking negative. So again, this would be 0, but this down here would be negative 1.571, because going down 90 is going to be the negative of that, and this would be negative 3.142 and so forth. But I hope we could see that that would be right in here somewhere. It would be negative 0.5 is between 0 and negative 1.5. So this answer would be quadrant 4. Now, I think that's hard to do that. The easiest way for me to do that would be change this to degrees. Well, I want to remind you something. Do we all remember that we said that 180 degrees was equal to pi? Now, we could come up here and use this formula up here. And we could call this d for degrees, and then we could come over here and put in negative pi over 6, okay? Which means these two things would reduce because you flip this one upside down because that's pi over 1 and multiply by 1 over pi. Okay, so these would reduce and these would reduce. So you get negative 1/6 times 180, which ends up giving you negative 30 degrees. Well, again, then you're looking at degrees, so negative 90 is here, and that's 0. But the fastest way is to not use this when you're given a pi. So do we remember 180 and pi are the same? So if I just stick 180 in wherever pi is, I can change that to degrees faster. So the fastest way to do this is just stick 180 in where there's a pi symbol, make it degrees, and then you can find a quadrant. So I'm going to do this one, part B, by just sticking 180 in there. So here's what I would do if I were you, because it's faster. So I would change this to 11, and then I stick 180 in for pi, because they're equal, and put that over 9. Then I would reduce these two. So 180 and 9 reduced to 20, because 20 times 9 is 180. And then 11 times 20 is 220 degrees. And then I would be using angles. So there's 90, there's 180, 270s to here. So 220 is going to be in here somewhere. So this would be quadrant 3. So I would change them to degrees first. And again, you can use this ratio, or wherever there's a pi, you stick in 180. Okay, so I'm going to clear this off. This next part says sketch the angle. So we're going to take these angles right here in radians. Notice this says 4. That just means 4 radians right there. That's what that means, because there's no degree symbol. And then we're supposed to draw these angles. So I'm going to do 5 pi over 2 first. So what I would do if I'm going to do 5 pi over 2 is what I just told you a second ago. This is going to equal 5 pi. And instead of pi, I'm going to change this to degrees. So I would reduce this to 90, and 5 times 90 is 450 degrees. So what I would do is I would start at 0 and start going by 90s. 90, 180, 270, 360, 450 goes to right there. I probably should have drawn a different color. So we're supposed to start here, and we go all the way around and get back to the y-axis right there. And there's my terminal side. And then I would call this 5 pi over 2, because when they give us radians, we're supposed to name these in radians. Now, to get what 4 radians would look like, the angle that would look like is, again, I would take degrees is to 180 as radians is to pi, and then I'm going to solve this by multiplying that by 180. I don't need the degree symbol though. Okay, so this, remember, 4 is radians, so I just put a 4 there, and so I'm going to type this in my calculator. When I type this in my calculator, I'm going to get 4 divided by pi, and then times 180. So that's 229 degrees, a little more than 229. So then when I draw this, again, I'm going to go counterclockwise, and let's use a different color. So I'm going to start over here on the positive right. I go around, there's 90, 180. Now, if I went all the way to here, it'd be 270. And this angle was 229.183 degrees. So it's going to be over here in this quadrant somewhere, right there. And then you would call this, you would write up here 4 radians, just like you put by the arc 5 pi over 2. So that's how you make a similar one. This says finding coterminal angles. Okay, now yesterday I skipped this part, so I did another video. So if you didn't see that video, you're going to want to go back and look at that, how to how to do coterminal, but it means they stop in the same place. So yesterday we took the angle and we added 360 to it, and we took the angle and we subtracted 360 from it, and we got a positive and a negative angle. And I showed you sometimes you got to do it more than once to get the other kind, but you need one angle that's positive and one angle that's negative. Well, now they're in radians, so there's two ways to do these. One is, if we go back to that unit circle, one is we added and subtracted 360. Well, we could add and subtract 2 pi. So what you could do is you could say that 5 pi over 2, 5 pi over 2 is, wait a minute, that's not the right one, we're down here, 2 pi over 3, sorry. So 2 pi over 3, we want a coterminal, is we could add 2 pi to that, just like we added 360. And we could take 2 pi over 3 and subtract 2 pi from that to get coterminal. Well, this is a little complicated because we have to get a common denominator here. So we would have to multiply this by 3 over 3, and this one the same way, 3 over 3, so that when we redid this, we get 2 pi over 3 plus 6 pi over 3. Which would end up giving us 8 pi over 3. So that would be a positive angle right there. And then we would take this 2 pi over 3 down here and subtract 6 pi over 3. And 2 minus 6 is negative 4 pi over 3. So that right there would be your, this would be your positive coterminal. This is your negative coterminal. So you're going to add and subtract 2 pi. Now, to me, this is the easiest way to do this, but a lot of you have trouble. A lot of you have trouble with pi being there. So what you could do is this. I showed you this on your calculator, and I'm talking about getting the common denominators, the hard part on these. So what you could do on your calculator is don't even put the pi in there, because if you put the pi in there, you're going to get a decimal answer, because pi is an irrational number. So you can take 2 divided by 3, which is what's with the pi, and add 2 to that and get a decimal. And if you remember yesterday, we can take that number and hit math and hit number 1 to change it to a fraction. And that fraction is 8/3. And if we go back over here and look at this problem, remember we had 8/3 pi. Now you got to remember, you got to put the pi back in with it. But your calculator will do this calculating for you, but you don't put the pi in here, because if you do, you'll get a decimal number that will not go back to a fraction because of the irrational value of pi. And then the other thing you would do is you would hit 2 divided by 3 minus the 2, and then hit math 1, and there is the negative 4/3 pi, which is the negative answer that we got down here. But you got to remember, you got to put the pi back with it. That will not show up on your calculator. Okay, so we added 2 pi up there and we subtracted 2 pi here. But again, we didn't put the pi in the calculator, because if you do, you can't change that back to a decimal. But you have to remember that you're doing it on here. Okay, this next part says complementary and supplementary angles. So this is a little bit similar. So yesterday, again, we talked about complementary angles were 2 angles that add up to equal 90. And supplementary angles were 2 angles that added up to equal 180. So now we're in radians. I'm going to do 18. So my angle is pi over 2. Okay, wait a minute. That's a 3. Pi over 3 is my angle. Okay, so if I want to get my complement, I'm going to go back and show you again. 90 is pi over 2. So just like yesterday, we took 90 minus the angle when it was in degrees. So to get the complement, we're going to take 90, which in this case is pi over 2 minus pi over 3. Now something you need to recognize is this is a 1 and this is a 1. So the long way to do it is get a common denominator. So you would take the pi over 2 times 3 over 3 minus the pi over 3 times 2 over 2 Okay, so this would give you 3 pi over 6 minus 2 pi over 6, which would end up giving you 1 pi over 6. That is the complement. Then over here, if you remember, 180 is equal to pi. Maybe I should put this as pi over 2. So go over here to get the supplement, you would take pi minus pi over 3. And again, you'd multiply this by 3 over 3 to get a common denominator. And this would give me 2 pi over 3. This would be my supplement. But you can do this on a calculator again, because what you got to know is there's ones in front of here, and you can do your calculator just like I showed you without using the pi button. You're just going to use the fraction. So if I take my calculator and I take 1 divided by 2, because it was 1 pi over 2, and I say minus, and then it was 1/3, and I'm talking over here, right here is 1/3, so I take 1/2 minus 1/3. I get that decimal number that looks a little crazy. I can hit math 1, and that's 1/6. And if you look right here at my answer, right here, this is 1/6 pi. I got to put the pi back in there. And then the other one, this is 1 pi minus 1/3. So I take, let me put my camera back up. Just trying to show you what I think is the easiest way for you. If I take 1 minus 1 divided by 3, I get that fraction. And I hit math 1, and there's my 2/3. If you look right here, we got 2/3 pi, but you got to stick your pi back on there. What's the difference between supplement and complement? Okay, complementary angles from definition are two angles that add up to 180 degrees. Like I wrote, I'm sorry, complementary is two angles that add up to 90, which is this in radians is pi over 2. Okay, and supplementary angles are two angles that add up to 180, which is pi. So the difference is complementaries add up to 90, supplementaries add up to 180. But when you're talking radians, that's pi over 2. And when you're talking radians, 180 is pi. So that's why over here, if you remember yesterday, we took 90 minus the degrees and 180 minus degrees, but now we're doing radians. So it's pi over 2 minus the radians and pi minus radians. Okay? Now remember, when you're doing complements and supplements, if some of these will give you negative answers. So if you get a complement equals a negative answer, some negative pi over something. If you get any negative answers, this does not work, and the answer is none. There is no complement because you can't do negative complements. All right, we're going to come over here and we're going to convert these to degrees. So I'm going to do one of these. Again, if you remember, we already did this earlier, that pi equals 180. And again, if you want to do the proportion, you can do this, but it's way faster. Now remember, these are radians, so you would stick these in where the R is and solve them. But it's way faster to know that pi is 180. So if I'm going to do this 5 pi one, I'm going to stick 180 in for pi. And then I would just take my calculator and I would take 5 times 180 divided by, well, maybe I should show this to you. So I am taking, right here, I'm taking 5 times 180 divided by 4, and I hit enter, and that would be 225 degrees. And you should put a degree symbol with it. So all you're going to do on these is put 180 where the pi is and get your answer. And then down here it says converting radians to degrees. And this one says round to 3 decimal places. In other words, it may not work out all beautiful for you like this, but we still do it. So I'm going to do 44 here. Again, I'm going to put 15 times 180 because I'm going to stick 180 in for that pi. So when I do this one, I'm going to take 15 times 180 divided by 8. And this one does not work out all pretty. It's got a decimal, but that's okay. So we would put 337.5 degrees. Now, this one is even going to be a little uglier. Now, this is radians because there's no decimal here. So I would use this one on this problem because there's no pi to plug into. So my degrees is to 180 as negative 0.57 is to pi. And then you're going to multiply that negative 180 over to that side, and you're going to get negative 0.57 times 180 divided by pi. And we're going to type that right there into our calculator. And we're going to round it to, it says 3 decimal places. So when I do that on my calculator, I'm going to take negative 0.57 times 180 divided by, and you hit second caret for your pi button. In case you don't remember, right there in blue, right there above my fingers, the little pi symbol. So you hit second caret and you hit enter, and this would be negative 32.659, negative 32.659 degrees would be our answer. You put the degree symbol in there. That's decimal degrees. Does anybody have any questions on any of this stuff? Now this homework should not take very long. Okay, there's not really that many problems. So, okay, I think we're done. So you guys, again, you're going to email those to me right now, and later on I may start